Greetings, welcome to number 3 of TeXarcana, and today's topic is macros, writing the control sequences. Oh gosh, I don't know how to start. Yes, you have a question, that'll help me start.
This is just about the homework you gave out yesterday.
Right.
In problem 4, where you're supposed to be plotting points, where do you want the origin placed?
Well, that's ambiguous. So in the program that I wrote, I think I assumed that that the points were given in units of VU, and then I used some arbitrary thing so that this one would work out. It wouldn't go off the left of the page. So I moved it in an inch or something from the left margin, and then I went down about 4 or 5 inches from the top of the page, and I cropped it to make this handout. I just took a scissors and pasted a bunch of things together. So you could make that specifiable by a user if you wanted to, but it is certainly ambiguous. And if you have the wrong origin, it just will print somewhere out in limbo.
I just arbitrarily placed it at the center of the page.
But I didn't make my macro figure out that it would fall on the page and adjust accordingly. That would have been a little more complicated.
Thank you.
All right, we'll talk a little more about these problems that anyone's having with the problems after I get started. Okay, now control sequences give you an enormous amount of power. It's almost impossible to conceive of what you can do with these control sequences, even though the definitions are comparatively simple. The chapter of the TeX manual about control sequences has this one weird example that shows you pretty much about everything, what the basic rules are for matching the parameters, getting started, and then how substitution gets done. And you go through different phases. First, you think control sequences are very simple, and you'll use them only to make an abbreviation for a dozen characters or so. And then you start to see that you can actually you can use control sequences to save information, and not really, the user never uses the control sequence, but just the macros uses control sequences to communicate between macros, between output routine and the main program, and so on. And then you come to the situation where you're thinking control sequence can do everything. Then all of a sudden the thing won't expand at the right time, or it will expand at the wrong time, and you're beginning to figure out that it won't be able to do anything, and you have to fight with them a little bit in order to get them. Now that's a little bit unfortunate. On the other hand, that's part of the game, and it's a challenge that sometimes keeps me busy for several hours, and I can't say that those several hours are pure joy, but having solved the problem afterwards is fun. The main thing, though, is I wanted to have something where you could define the rules for control sequences briefly and write the code in a small amount of time. That implementation wasn't too much, and I got a lot more than I expected I would get. But I don't. On the other hand, I don't claim to have the world's best macro package in TeX yet.
I'm sorry to interrupt. There's an incredibly high-pitched squeal coming back here. It was done. It was coming, and it's going to be. It came on and off again.
Yes.
Did anyone hear what I said about control sequences?
Yes, it's something like.
Like on Dr. Strangelove. Okay, then you realize that some of the facts about control sequences aren't as simple as we thought they were, and that the rules for exactly when things are expanded and are a little bit implicit. And I have to admit that sometimes I get surprised at what happens, and this is true of every macro package that I know. That is, you start out thinking that it's a rather simple thing, and then you start looking at how powerful it is, and you see the combinations of things that you can't imagine what it's going to do. And the thing is unambiguous, but in its own funny, ambiguous way. And so macro packages, I think, have historically always included a way for you to trace and find out what it's doing, so that you can really figure out these inscrutabilities. Now, that's something of what I want to say today. That is how we can coerce the macro package to do what we want it to. Last week I mentioned the two phases of text input, which I called the mouth and the stomach. And the mouth is the part that eats the things out of the text files and things that you type in after a star prompt on your terminal. And the stomach is the part that actually sets type and does the semantic action. So you could also consider this syntax in semantics. The mouth part of TeX uses these, classifies everything it reads from a file or the terminal as one of 14 things numbered 0 to 13, and this code associates a number from 0 to 13 with each of these characters. This is done at the time that the thing first goes into the mouth. So whatever the values of the codes are at that time governs what the mouth is doing to them. And once they're classified that way, that classification stays. So, for example, when you define a control sequence, the escape character that was in effect after the word def was read is the one that identifies the thing after the def to be a control sequence. All the other the code a left brace that follows that again has to be recognizable as a left brace character. It doesn't have to be a left brace symbol. It just has to have code 3 or whatever. Yep.
So if you define, say, a backslash to be your escape character, you read in a certain, with a macro, you read in a certain escape sequence, while backslash was the escape character. You passed it into another macro, which redefines escape to be a normal printing character. There's no way that still will be a...
It's still a control sequence with the same name.
And there's no way to explode that apart. Is that right?
You can change that. Once it's gone into the mouth, it's been classified. The control sequence has been stored.
And you can't break it apart into letters. You can't explode it.
No. You want to explode it into letters, you can send it to a file.
Okay.
And the send statement will put it on the file, and then you could read that back in from the file again. But that's the only way the stomach can get back to the mouth is through because the mouth will only, the classification process has done it. Okay. Now, for example, if someone says def, okay, let me show you what I did in the TeX manual itself in order to print sort of arbitrary strings of text. Can we have this on? Can we have this on the screen? I defined a macro that was backslash equivalent sign, and the beginning of that macro started out with various things that would change codes. So I changed code of I don't know what these numbers are, but I think 44 is a dollar sign, for example, and I changed that back to a 12, which means other characters. So now this says that henceforth, when the mouth sees something, if after this definition has taken place, then the mouth will classify a dollar sign as 12. This isn't very well focused on my screen. I don't know if you can see it any better. And I changed all the other things. I changed back all the other things too, so that everything I typed would be like another character. Except I needed one escape, one way out. And so I changed, the left braces and everything were changed so that they wouldn't be, I could type, later on in my text I'm typing something like this. I put a left brace, and then I started this control sequence, and then I would type some random text, like input basic, or I could say, let TeX would not interpret this as anything special. It would be just text inside of this equivalence mode. On my keyboard, equivalence was a nice symbol to use. And so you could say, well, I don't know what the example I should use here. I could say def of this, almost. No, not quite. Def of A to be something or other. Okay, so this left brace wouldn't be the same as a right brace. I could say in my text, if I just wanted to refer to a left brace all by itself, I could refer to a left brace. And then I got out of that by saying equivalence backslash and coming back again. It looked sort of symmetrical. Okay, and so I could print a left brace in that font by typing this. This is the way I set up my macros to do it. So there was this little ritual that I type these 3 characters, then I have verbatim, and then I have 3 characters to come out. Except there had to be one way to get out again, and so I also coded the equivalence symbol to be an escape character, and I wouldn't allow myself to type equivalence symbols in here. So this equivalence symbol is the escape character. All right. So I don't know what the code for equivalence is, but let's assume for without loss of generality, that's 23, and I think the escape character is type 0. So I changed that to 0, let's say, and then I also selected the typewriter font, and I think that was I defined a few other. I also had in here, I think, a couple of other definitions. For example, I think I defined less than or equal to be superpose an underline onto a less than sign, because in the typewriter font it doesn't have a less than or equal, and so I had to define a few special things like that in case I wanted to get a less than or equal into my example. So I defined a few other symbols. Now notice that in this definition I'm using backslash still as the escape character. I'm not, here I changed the code of backslash, whatever it is, to be type 12, backslash to be type 12, but I'm still using it as an escape character in this def and everything else. The reason is that this code hasn't taken effect. This is just a piece of text. This is a control sequence to code and an apostrophe and so on, but this definition is the mouth is just reading this in. Using its present meanings of all the symbols. It's not acting on this stuff. It's just reading it in, storing it away. Now actually what happens to a control sequence after it gets classified by the mouth? It gets stored in the I can't really call it the brain, but we could call it the nervous system anyway. So TeX somehow has this long string of text with everything classified into each token, one thing at a time. A token like this has been classified as one token, and it's a particular pointer to a place in TeX memory that is associated with that control sequence. If you redefine that control sequence, the new definition will take place when I refer to that part in the memory. This is a character, this is a character, this equal sign, all of these are, this would be a digit. I think it's classified though as another character that's just recognized to be between 0 and 9. So it hasn't been classified as any, the 1 is just there as a 1. It the mouth doesn't convert that into a number 12. It just takes it as a 1 followed by a 2. So all of these things are just are stored away as a long list according to the classifications that were in effect at that time. Then I also define backslash afterwards, and this is the one that's eventually going to be equivalence backslash when equivalence becomes the escape sequence. This is the control sequence that's escape followed by that backslash. See? So that's going to be the one that does everything that I have to do when coming out. Now, is there anything I have to do when coming out? Just by getting out, I have to be able to. I think what I do is I change the code of the right brace back again, which is different on different ASCII codes, but at Sale it's 176. And I changed that back to a right brace, which I think is 2 or 3. I forget what the code is. These codes were never made mnemonic, I'm sorry. And then that's all. That's all this control sequence does. It's enough for it to recognize the right brace. I think I need a space here. It's enough for this to recognize, because otherwise it'll scan the right brace to see if it's part of the number, and while it scanned that right brace, it still thinks it hasn't changed the code yet. So I need a space here in order to give the stomach time to get the information. Okay, but after that is true, then the right brace is enough to be recognized, and then that'll end the group, and all these other codes will go away. So I don't have to uncode everything. Just get out of that group. Okay, but that's about the way these control sequences work, and I think it gives you some idea as to how the value of codes at the time the mouth gets it is the important thing. Once the mouth has parsed it into one of its tokens, classified it, then it stays that forever after. Mouth also is the one that knows the rules about when to put par in for a blank line, when to ignore several spaces in a row, and so on. That's all based on the classifications of these characters.
If you put the definition of backslash within the text of backslash equivalence, so that it would,
that wouldn't have hurt.
That wouldn't have hurt. That would free up the backslash.
That would free up backslash as a macro that I could define. It's kind of a handy one to define because it's so easy to type. You can hit the key twice, and so that's right. Actually, I could put that in there, and that would have been better. Yeah. Okay. Now, so then the stomach takes effect, and the stomach. There is a little bit of communication to that goes on in between the mouth and the stomach, and that is every once in a while some of these stored definitions are regurgitated, or whatever you want to call it, that they come back through because you have to expand a control sequence. It's time for the stomach wants to read something, but it has to get it not from the source text, but it's interrupted by a control sequence. And so you get in the middle of a control sequence, and that calls in another one that has to be user-defined and has to be expanded. And so you get a stack of things inside of other things inside of other things. Sometimes, in fact, TeX will read and decide it didn't really want that one, and it's going to read it again. Like when it's looking for a dimension, or it's looking ahead to see if you wrote PLUS, to see if there was any stretching in a glue, and maybe the text said PLUD or something like that, or PLU anything else, and then TeX will say, oops, that wasn't plus, there was no glue here, put it all back, and it comes again. So sometimes it has to back up over symbols that it's read and give them back to you again. Then, besides, one of the things that can appear is the word input, and that will start reading from another file, in which case the mouth will have to actually do the contact with the file. So you have this big stack of things coming on input. At the lowest level is the terminal, then probably a file, and then probably some control sequence, and some control sequence maybe something that was backed up, and then maybe another input from a file or something. This can get rather high. Right now it can get up to 80 levels, and the human mind apparently can only handle about 7 at a time, according to Ingve's depth hypothesis. Now this is the way the input gets to the stomach. Now the stomach is where all the semantics takes place, including if. And this is what's a little bit disconcerting at times, and that is that things like if and all the other tests that you have here, and then else, are done in the stomach and not en route to the stomach. And so that means that the word if will not be recognized unless it will not be interrupted in the midst of something else. Suppose you're trying to scan for a number or a dimension or something like that, and the word if comes along. That won't work. You can't you can't say if something then points else millimeters or something and put that after 15 and expect to get either 15 points or 15 millimeters. I believe that's true, isn't it? I think you can't do that. I think because you... That's right. It'll put points in for you, and then you get an error message saying unknown dimension when you got to the word if, you see. So if is at a little awkward place there. It's only ready, TeX is only ready for it when it's ready to see what's going to go next into one of its lists, not when it's scanning for funny things like that. So what you have to do is, instead, you XDEF a, you define a control sequence in a way that gets expanded at a time when TeX is ready for the expansion that will come out either points or millimeters. And so you would define the control, so you would put before the A-skip, you would say, define, maybe GDEF a control sequence to be if something then points, else millimeters. And then you use that GDEF control sequence afterwards. So the idea is that when if is done at the wrong time, we usually have to put the result of the if into a control sequence in the middle here, and typically with a GDEF of the result of something or other to be whatever you wanted to do in that case, and then GDEF on the other case what you want to do in the second case, and then GDEF res, and then afterwards you can call res, and that will expand at the right time. So if won't expand as a control sequence will. If is done only by another part of the stomach. Now this has some disadvantages when you're designing macros that you have to keep track of it, but there seems always to be a way of getting around it. And the advantages of it are that in various contemplated extensions to TeX, they won't all have to handle every if that exists in the system. So they only have to handle a few of them, something like that. Anyway, I thought it was an advantage at one time. Now, so the difference between the mouth and the stomach is important to have in mind, and those are the best analogies I can think of. This will arise in connection with problem 5 or 6 of your exercises, number 6, I think it was, in a strange way. That is, if you do by one obvious approach, in the end of the list, after you've put out a carriage return into your list, then your macro might expand into something that has an if to test whether the recursion is done, whether you're at the very end of the list, and it'll turn out that what happens in an alignment after the word carriage return, TeX looks ahead to see if the next character is no align or not, and if it's no align, then it will stop the alignment. However, if the word is if, the assumption is that it's not no align, and that there's going to be something there which then has to be followed by a carriage return. So then it will tell you that you're missing a carriage return after your if there. And and in fact, this if will also get stuck into the middle of your alignment on the next row. So this needs to be anticipated in your solution to problem 6, and that's one of the reasons I gave that problem. Okay, I talked about difference of that sort. Let me see what else I wanted to mention. XDEF was something that was added after I started the very first versions of TeX had def and GDEF, and I found I needed GDEF because of cases like this. I couldn't just use a def here. If I use a def here, does anyone see what's going wrong? Because this is all done in the stomach. Yeah, you got it? Put the microphone.
The definition would disappear once you leave.
The definition goes away when it hits the right brace, because the right brace and end of a group is also done by the stomach. And the right brace says go back until you find the corresponding left brace and then figure out what routine you were in. And then it sees it was doing an if. And so the def had disappeared by that time, any defs in there. So I needed definitely a G-def to get out. A similar thing, I think, possibly in an output routine, although that I flipped on that once. I'm not sure if the output routine is really considered to be inside of a right brace or not anymore. It's not. I don't remember, but GDEF is something that was necessary to mean that some control sequences would be considered only at outer level and not redefined. Now, XDEF was something that I had to add a few months later when people started to use macros more heavily than I had originally intended. When we started to realize that they were of some use, and this is so here we have a control sequence, and then whatever text is put in here, the macros are expanded. This just means that it's as if all the processing that is done that takes things to the stomach. But an if will not be expanded at this point, for the same reason. An if in here stays an if. So if this is a recursive, if you call a recursive macro inside of here that has ifs in it, you're going to get in trouble. It's not going to expand that recursive macro to the right number of times in an XDEF. That doesn't happen. So that's a limitation that you'd have to solve another way by finding some part of text that's consuming the text and then getting that in. But XDEF won't do it. Now, let's see. Another thing so XDEF usually is just a simple usage of the thing, and the only thing that of course for grand wizards like the people in this audience, I have to mention some of the things that if you want to make a long XDEF and do something really strange, this is a way to expand a control sequence pretty much, except without the words the ifs. One of the things sometimes people say, well, what if I have a control sequence in here I don't want to be expanded? So there was a non-expand in there, and it had been defined to be a user something, but I wanted to XDEF and I wanted to expand everything but that one. Well, how can I do that? Well, as far as I know, there's two solutions to that problem. One of them is to precede non by a word like X quote or something like that. And before you did the XDEF, you define X quote, or no, you say let X quote equal def. Now, while you're expanding something in an XDEF, it doesn't expand any control sequence that follows a def. And so if I said let X quote equal def for the time being, then non is following def, and so it's not. This let has said that the meaning of this control sequence is exactly the meaning of def, and so it's that type, and so it won't expand a control sequence following the word def. Then after the XDEF has taken place, then you can define X quote to be null, and then its effect will go away when you actually read this, because it'll expand to null, and I think it'll work okay. Now, the other solution is, if you don't understand even the problem, then don't worry about it. I'm not going to dwell on this for long. The other solution is to define save non, or let save non equal non, and this means that anything that non was is now saved in save non, and then you say let non equals just about any primitive, like you could let it equal let. Anything that won't get expanded, any primitive at all. So then when non appears in here, it'll look like an unexpandable thing, and it will then appear as non. And then afterwards you can let non equal save non and it gets back again. And so that's another way to prohibit expanding of that guy inside XDEF. Okay, so the main moral of this story is, though, that sometimes you get in trouble if things are expanding when you don't want them to, they aren't expanding when you do want them to, and the hardest thing would be find a case where the stomach is actually wants to find a case where the stomach is going to want to expand a recursive macro for you. And one of the best cases of this is after the word if. You can put the routine that looks at the two characters following the word if is a big consumer in the stomach, and it'll expand everything until it gets two characters out. And so that will do some expansion, I think, for you. Maybe not. No, I'm sorry. You can't get ifs in there. Oh well. Push back again. Let's see. Once I did it through marks. I think there are ways to get around every problem, but sometimes I haven't got a general solution to them all, I'm sorry to say. In fact, the subtleties of this problem are somewhat overwhelming, but I think John Backus did solve them once after spending 5 years on the problem of how to define such languages. And if I live long enough, I'm going to learn how he did it. Now, let's see. I talked about that, X quote, and codes. Now, oh yeah, one time that people wanted to get a macro to expand was in the preamble of an H-line. This one. Suppose we've defined a control sequence to be a preamble that says this is the way to do a 3-column format. So you would say, so they wanted to say H-line of 3-col carriage return. Now, when the H-line routine is reading this preamble, unfortunately, or fortunately actually, it doesn't expand all the control sequences at that time. In fact, it would be kind of dangerous if it would, because a lot of times in the preamble there are things like center, left bracket, star, and you can imagine a macro that would actually use its argument and duplicate it several times, and then you'd have several stars in that preamble. Doesn't work too well. So generally speaking, H-line just scans right through this until it gets to, and it knows only the sequence of the things that are typed carriage return or a tab mark, and everything else is just filed away into a list that's going to be and oh yeah, it also knows this symbol. And so, like if it was H-line center of something, then it saves away this part of the text to be put in front of whatever you typed in that column, and saves away this part of the text to put after whatever you type in the column, and it marches on to the next entry till it gets to a carriage return or something else. So how are you? You get into trouble if you really wanted to expand. The 3-col was defined to be equal to center, three centers separated by tab marks or something like that. Okay, well, there is a way to expand that, and I'm sorry to have to admit it. Please don't tell too many people. But you say in front of this tab skip 0 point. Now, the other thing that H-line has to look for as it scans the preamble is changes in the amount in the tab skip. Tab skip is changing, would change the amount of glue that goes between columns. And so when it sees tab skip, then it starts to go through the regular routine to scan for dimensions, to scan for glue. And so it'll have to look for the word plus following this dimension here. And so it has to expand 3-column to see if it starts with the word plus. All right? And so 3-column will get all expanded and everything will work beautifully. Okay? So that's the solution to that problem. So there are ways of getting things to expand. Sometimes they expand a little bit that you don't realize they're expanding. At the end of a number, if you're saying any example where you're giving a number, like even code of something equals 12, and then if the next word to that is def, well, Tech had to look ahead at the next symbol following 2 to see if that was going to be another digit. Okay? Now, it actually would have, if that was a control sequence, that control sequence would have got expanded then and there. It would have read ahead to look at all its arguments. It might have gone through many lines and read down the page a long ways, just because it's trying to find if there's another digit after that too, before the stomach gets, before that part is found. Then in order to just scan the word def, though, and suppose there wasn't another control, whatever control sequence it was, well, you also had to look to see whether the end of that control sequence occurred. You had to, you don't just stop at the D, you have to keep looking ahead. And so the symbol following def has already been classified by the mouth by the time. So what if that was the symbol that was just being Checoded here, like if it's a type 13 instead of 12? Then there hasn't been time to classify that symbol properly. So you need a space here in order to suppress that amount of looking ahead. And after you see why, you realize that that's natural. It had to look there because otherwise it wouldn't know to stop. But when we look at something as a page as a whole, instead of one character at a time uncovering, we get a different viewpoint sometimes as to what the computer is going to do. So the way it really works is symbol at a time, and if there was no space there, it would have to, different parts of it are all working on these things. So that's where some of these mysterious phenomena occur that I think you might run into as you're solving those problems for tomorrow. One more thing I got to say about this before I go on, and that is after you get to the end of an if part or an else part, let's take else as an example, then TeX looks ahead at the next symbol to see if it's a space or not, because spaces are supposed to be ignored after the right brace of an else. It's typically a nice way to end the line when you're defining things, and so it actually looks ahead to see if there's a space there. Now, sometimes this causes a mysterious disappearance of spaces. So like if you had a long macro and it ended right there, then outside that macro it might be pulling up a space from that you didn't think was going to be called by the macro. For example, usually after a control sequence a space is ignored, but if the control sequence has a parameter, then a space after that parameter won't be ignored. So if I call somewhere CS of something delimited by braces, I don't expect the space here to disappear. But that space would disappear if that CS ended with an else that had no, and the else at the end of that control sequence would gobble up that space. Again, that's something that you'll probably only run into once a year, but if you see a mysterious disappearing space, think about putting another space before you end that control sequence, because else always will look for a space there, and if it doesn't find one, it has to back it up, whatever it found, and put it back. I think it even might expand the control sequence at that point, if it whatever it finds after it. So it's a precaution to put a space after the closing of an else. All right, now recursion is the next thing I wanted to mention. Recursion is where a control sequence calls itself, and it was after I had defined TeX, and when I looked at the first implementation of prototype TeX that had been made by Michael Plass that following summer, that I first realized that control sequences could be recursive, and that I would have to and find. In fact, Michael was one of the people that opened my eyes the most on the power of these control sequences. His first test program generated an almost infinite text, and it proved that my original ideas on the data structures were completely inadequate because I had to keep reference counters on the expansions of macros, since I can be in the middle of one macro and simultaneously redefining it, but the text of the old definition can't go away until I've finished on a lower level scanning to the end of that macro. And so so I learned this first about 6 months after TeX was originally designed. But let's write a simple recursive macro. Let me to show you that control sequences actually have a lot of the power of a finite state machine. Let me count how many periods there are in a row. Let's take that as an example. And I'll have a text that consists entirely of periods followed by some other character. Let's suppose, and we just want to call the count period macro. Okay, so define count period macro. And it's going to put the answer in counter 0. Okay. Okay. Now what I'll do is I'll start it out. Count periods, and I'll start it out by saying not counter 0. Counter 0 is normally the page number, so let's use count 7. So set counter 7 to 0, and then call say CP, which will be the recursive part of this that actually does the counting of the periods. Okay, so now I define CP of one argument, and so that's going to read in the next symbol, either a period or something else. And so what it's going to start out is going to say if period number 1, then do something else, do something else, right? Else finish the whole job. Now what I really want to do, this is what I'm first going to write down is not going to be the final solution, but what I really want to do is advance count 7 by 1, and then I want to call CP again. And that'll gobble up the next period and keep on going. Else I just want to repeat the thing that terminated it. I don't want to gobble it up. I want to repeat it, just saying that, and put it back into the text. So I've already done my counting, and that will stop it. Now this would be a recursive definition that at least intuitively solves the problem. It says if you see a period, increase the counter by 1 and try again, gobble up the next character. If you don't, then just replace the character you looked at. But the problem is that you see what's actually happening when you watch these macros getting traced, and it'll trace the if, and it'll see that these are equal, and then it'll advance the counter, and it'll call CP, and CP is going to look for its argument. Well, its argument is this right brace here. And it's going to give you an error message saying a right brace detected, unmatched right brace detected in an argument, and then it'll get all screwed up. In fact, you can even gobble up a right brace after the word if. When the word if is followed by a right brace, you can get your brace structure all messed up. I hate to think what would happen there. There's probably one of the error messages that TeX will produce is called "This can't happen," and it just means that I couldn't think of a way in which it could happen. But I think maybe with an if followed by left or right bracing, you can get things all screwed up. And please don't do that ever. You might blow the fuse. Okay, then so CP would. So how are we going to resolve that? That's the intuitive way, but the real way now that works is something like this. Okay, if you see a period, number 1, okay, let's advance count by 7. That's advance count 7, and then I say gdef, not def, but gdef next to be CP, and that closes the if. Now we say else, and then comes gdef of next to be number 1. And finally, after we've done the if and the else, now we've safely recovered from all this testing, then we say next, and that's the end of CP. Now next is either CP again, which will now not gobble up this right brace. This right brace disappeared when I defined CP here. That's just the end of the CP list. And so that is ready to look at the next character of the text if it's CP. But if it's number 1, it just repeats that and puts the thing back again. Okay. So that's an introduction to a recursive macro, and one of our very first test cases was to calculate the GCD of 2 sequences of periods. Jim?
I think there's one case where you can run into problems, and that's if the thing that immediately follows the period is a group.
That's right.
Then you're going
That's right. It has to be. Yeah, absolutely. If you put something in a group, if you put something here in braces, okay, then that would get gobbled up here by next. I mean, sorry, the braces get removed when that parameter is matched, and then you stick in several things after the period here. Now, it turns out that the way if works. Oh yeah, that's something I wanted to mention. The way if works, if the result is true, if the result is false, the way it finds where the else is, it goes ahead until it gets to the next right brace on the current level, and so this text, this argument number 1 might be quite long, as long as it doesn't have any other groups inside of this group. It would scan to the end of that until it got to this right brace, and then it would find the else. Okay. However, if this thing here started with a period, then this relation is true, and it will expect to find a left brace immediately thereafter. Okay, and then it will start scanning that text, and you could even put in here something followed by an else and get things royally mixed up. Okay, now. Yeah, I'm glad you think it's funny. and then another thing that could occur is if you had something, like x at x, but you also have another brace in there, because that brace is going to be where it expects to find the else after in the false case. So the way if works is if the relation is true, and all relations actually work this way. If after you've scanned the part that decides what the relation is, like there's an if dimen, and then you can give one dimension equals another dimension, for example. There could be other garbage here if the relation is false. It's going to just scan until it gets to the next right brace that's at level 0. But if it's true, it expects to find the left brace for the thing immediately. Is there a question?
Yeah. The way you've got it right now, the number 1 will match a period at a time. Is that right?
That's right.
Could you not also define it so that it had 2 arguments, a number 1 followed by number 2 followed by some marking character which you'd be required to put after the sequence?
You got to watch out that that braces get stripped off after. So I would have to know some terminating point afterwards.
Suppose you had a specific character you'd use to mark the end. Then number 1 would match one period, number 2 would match the whole rest of them, and you just pass number 2 to the recursive call.
That's right, or I could pass the whole works again and make an n-squared method instead of an n method sometimes in order to avoid a problem like that. But there's actually a better solution. This was just our first introduction to recursion, okay? And so I want to talk about that. Can we pass these out? Everyone get a copy of this recursion paradigm. While we're passing it out, I want to show you one other useful gimmick before we get, and that is using control sequences as counters. Now there's 10 counters, 0 through 9, and actually that's more than most people think, but people are afraid to use more than 3 or 4 of them for fear of running out. And you cannot, but there's essentially unbounded number of counters because any control sequence can be used as a counter, and it works like this. You define stole count number 1, number 2, and this will take 2 arguments. The first one is going to be the name of a control sequence, and the second one is going to be the number of a counter. So a typical call on this would be stole count, pseudo counter 3, and that will set whatever is in count 3 will now be defined. Pseudo will now be defined to be the value of 3. And the way you can test that is to make it work in all cases, including negative numbers. We'll first test to see if the counter is negative. If so, we gdef our parameter 1 to be empty. Otherwise, we gdef parameter 1 to be a minus sign. Then we, before getting out of that else branch, I want to set count of number 2 to negative number 2. And that will be the end of the else part. Then I do an xdef, because xdef expands counters, and I xdef number 1 to be the current value of number 1, which is set either to blank or a minus sign, not blank, empty or a minus sign. followed by count 2, number 2, and then I've done everything except in one case I have to restore count 2 to its negative, and a neat trick for that, invented maybe by Jim, here our TA, is set count number 2, number 1. This will now is the opposite of stow count. Set count 3 to pseudo is the way of getting back the pseudo counter into count 3, and that's what this is doing here. In fact, to restore the previous value of it, because it's already number 1 has now been xdef to be. Let's take an example that the counter contains negative 123. Okay, then I gdef pseudo to be a minus sign here. Don't forget a space after what? I probably need a space in here somewhere in order to make sure that the number has ended. Is that what you're saying? Yeah, I need a space there because it'll look for a space to terminate the number. Yeah, thanks. Suppose the counter was minus 123. So first I define pseudo to be a minus sign, and then I change count 3 to be plus 123. Okay, then I did an xdef of pseudo to be minus count 3, which is now minus 123, and that gets expanded because it's xdef. Then my last thing says set count 3 to pseudo, which by now is minus 123, and it all worked. Jim, did I screw it up? Here. Okay, if you want the counter to have the space after it, I see, that's safer, yeah. Okay, very good idea. Put a space there. Thanks very much. Now, except that fails my next example. If the space isn't there, no, oh gosh, maybe we can't have everything. I was going to now say if 0 pseudo. Okay, I think maybe you're allowed spaces at this point before the left brace. Yeah, I think you are. Okay, so you're all right. If 0 pseudo something else, something else. Now, the idea is that if pseudo is 0, it will match with 0. But it would be 0 followed by a space, and I think that it'll skip over a space to get to the left brace. But if it's anything non-zero, even though it's a long string of symbols, it'll go into the else branch. And so this is a way to test a pseudo counter for 0 that's legitimate. All right. But now to recursive paradigm. Time is. Okay,
before you put that away, on the xdef line, I notice that you're saying xdef number 1 is number 1 from the argument to stow count, rather than using, let's see, but you've gdef'd that before, so
yeah.
You're essentially referencing it by its name passed in, not by.
Yeah, it's efficient. I could have used another control sequence here.
Yeah, but if you used another control sequence there on the xdef, then it would probably go off and try to expand CS given an argument.
CS doesn't have an argument.
Okay.
So xdef will expand any user-defined control sequence, including the one that was up here. I think Jim did that just because it was cute, but also to show that you can define a control sequence in terms of itself. So a control sequence can grow. In fact, I use that in exercise 6. I define a control sequence to be something more than it was before.
Don't you? I presume you intend to have. Oh, I wish you'd leave the screen if you would.
Okay.
You intend to have spaces after, in front of your number signs. Like for example, here /xdef number 1. Wouldn't you want a space there because of number 1?
No, number is recognizable as a non-letter. Anything that's non-letter can after a control sequence of letters, you just have to have a non-letter to follow it. So you could put a space there, wouldn't hurt. It would gobble up the space. But the only value of a space after that is to delimit the control sequence.
Oh, I see. The difficulty would be is if you were passing in sequences of characters from macro definitions, and you could absorb a character into the macro.
Number 1 is that, but yeah. No. This part of the definition, the rules for spaces are what the mouth sees for spaces.
It'll be scanned at that time, right?
Okay, but number 1 is actually going to be a control sequence in the use of this macro. Okay, take a look at that. I hope you've copied it down. the way it was before I garbaged it up. Otherwise, ask me after class and I'll rewrite it for you. But I got to get to this recursion paradigm because this is a fairly general solution to recursion. And last night, after an hour and a half, I reconstructed something that I had done in 1959 and had always wondered how I did it. And it had gotten forgotten in the meantime, and the simplifications of it actually failed. So it was urgent that I reconstruct what I did. Anyway, okay, so the input basic, of course, is you don't have to do that to get recursion. But then I defined 3 magic control sequences, which one is capital T, which stands for truth, capital K, which stands for killing, and capital TT, which uses 2 T's in its argument. And it looks for 2 T's as delimiters of arguments. You see it has argument 1, and then ended by T, and argument 2 also ended by T, and it just returns the second of these arguments. So it's a sort of a half-killing thing. Now, that's a very tricky thing, which I'll talk about in a minute, but first I just want to give a recursive paradigm. Now, this is for a general class of operations where you want to give a lot of arguments to a macro, and the form of it will be the arguments separated by a delimiter. If the delimiter is null, then you have to modify this very slightly. But list of one or more things separated by semicolons is the example I'm using here. So I'm using semicolon as a delimiter, and here's a typical call on recurse. Alpha, semicolon, beta, end recurse. Okay, but I want to allow anything in there. It can be groups. It can, all of that stuff. Well, no. If the whole thing alpha were surrounded by a brace, it would be equivalent to the other effect, and there's a way around that too if you need it. But this particular definition will strip off if the whole thing is braced. Separate. So it could say alpha semicolon beta semicolon gamma, or it could just say alpha all by itself. One or more things separated by semicolons. And semicolon can be replaced by some other delimiter if you like, but they shouldn't occur, of course, except in closed embraces within any of the arguments themselves. Now, here's the way I can gobble that up, and the nice thing about this solution is that there are no forbidden characters in alpha and beta. There's a forbidden control sequence only. This control sequence T should not be used. Probably none of these 3 should be used in alpha in the list of arguments. But it's easy to forbid control sequences from people. I mean, one of the say that for example, one of the things I did was I changed the code of character 174 to be a letter, and then I actually defined these control sequence. That's the vertical line. I actually defined this control sequence to be T vertical line and K vertical line, and when I did the definitions, and then vertical line was thought of as a letter, and it actually fits right after Z a little bit, and so it'll print out as a vertical line and so on. But then after I've defined all of my control sequences that I want it to be private, that no user is going to match, then I change the code back of 174 back to 12 the way it usually is, and now no user is going to be able to conflict his control sequences with mine unless he really tries very hard by changing the code back to 11 and sticking it in again. Okay. Now, so there will be a forbidden control sequence in here, but no forbidden character. Now, the solution that someone said to problem 6 yesterday was saying, somebody said, can you assume that there's a certain character not in the list that you could use as a delimiter to know when you got to the end? And I said, yes, you could assume a $sign is not in the list. But the solution I'm presenting now it doesn't have that kind of restrictions in it. Okay, so recurse of one argument. Followed by end recurse. And so the argument is delimited by end recurse, and this allows you some flexibility also in defining macros. In math mode, you can now tell the user that it really doesn't matter if he has spaces inside because sometimes putting spaces between arguments can get tricky. So a lot of times it's nice to define a macro so that it has its own delimiter at the end. Okay, then you do initial computation, whatever you want it to do, and then you call recur of the whole argument followed by your delimiter and this trick. Okay.
Sorry.
Yeah, so this will be in the handout for the people that don't see the rest of this on tape. Also, there are people waiting in the hall, so I'm going to have to clear out soon anyway. Okay, I'll tell you how to read the rest of the handout. I define this, and the big trick occurs in this if test here. If t, number 1, all this jazz. And then I said macro trace, so you can see what happens. Now, macro trace is a control sequence defined in BASIC that will turn on the tracing of macros. And it turns it on almost immediately, but I had to have this blank line in here in order to get it turned on. Otherwise, it would have read ahead and seen this where it recurs before it was without tracing it. So that blank line was, so that's the time delay from getting from the stomach to the mouth. Anyway, this will trace macros, and then I have the call. Now, you can watch exactly what happened. This is what the macro trace printed out of recurse. It prints out the name of the macro and and this right arrow, what it expands to, what the argument's evaluated to, and you can watch. This is the kind of trace you get on your errors file after macros are expanded, and finally everything got printed. Then I showed you what actually the whole recursion expanded to, and this is initial computation, middle, compute with alpha, middle, compute with beta, middle, final computation. And that's a general kind of recursion that will handle many, many recursive problems. Okay? Now, there's one more handout. That's the challenge problem that I promised you. The challenge problem we can talk a little more about on tomorrow, but the main idea is I think, fairly clear. I got your source file. I write the source file here, and there's a place where it says secret code to do this formatting. That's your exercise. Fill in figure out what that secret code was. And I give you the rest of the source all written on here. So this is your challenge problem.